Let's review the exponent rules. You remember if you have a to the m times a to the n, then that is the same thing as a to the m plus n. So when we're multiplying powers of like bases, we keep the base and add the exponents. We have several power rules. The first one is when you raise a power to a power, you multiply the exponents. When you raise a product to a power, then you raise each factor to that power. And the last power rule says when you raise a quotient to a power, then you raise both numerator to that power and denominator to that power. Remember, when multiplying powers of like bases, keep the base, add the exponents. So when you have something like 2 cubed times, or 2 squared times 2 cubed, you can go straight to 2 to the 2 plus 3, which is 2 to the 5th. Remember, power rule 1, when you raise a power to a power, you multiply the exponents. So when you have 4 to the 5th to the 3rd, you can go straight to 4 to the 5 times 3, or 4 to the 15th. Remember, when you raise a product to a power, you can raise each factor to that power. So 7x cubed, you can go straight to 7 cubed x cubed. You really don't need the intermediate steps. Warning, something like mn squared is not the same thing as the product mn squared. The second power rule can only be used with an expression where you have parentheses. And then, of course, the quotient rule says that if you have a quotient raised to a power, you raise both the numerator and denominator to that power. So if I tell you you have 3/5 to the 4th, then you can go straight to 3 to the 4th divided by 5 to the 4th. Let's simplify these expressions. M to the 6th times m to the 8th is m to the 14th. When I have something like b, this big long product, use the commutative property and multiply all of your numbers together and then your r's together. So -5 times 6 times -3 is 90. And this becomes r to the 3 plus 4 plus 1. Now don't forget this one right here has a power of 1. So this becomes 90 r to the 8th. Now we're always going to assume our variables are non-zero real numbers. 7 to the 3rd to the 5th is 7 to the 30 to the 15th. Well, 2 to the 5th, y cubed to the 4th is 2 to the 5th to the 4th times y cubed to the 4th, which is 2 to the 20th times y to the 12th. Now, what do you do when we have these fractions? Well, remember this becomes 4 cubed to the 5th divided by z squared to the 5th. So this becomes 4 to the 15th divided by z to the 10th. For this last one here, remember the square goes for both numerator and denominator. So this becomes -3 squared times a cubed squared divided by b squared c to the 4th squared. So this becomes 9 a to the 6th divided by b squared c to the 8th. Remember, for any non-zero real number, a to the 0 is 1. And in this class, 0 to 0 is undefined. So if we were to evaluate these, 8 to the 0 is 1. -8 to the 0, now that negative sign is outside, there are no parentheses, so it is -1. Here, -8 to the 0, that negative is inside the parentheses, so it is equal to 1. For D, -8 to the 0 is -1. And then E, all of this mess to the 0 is just 1, as long as B does not equal 0. Now let's go over a few bit of vocabulary. The term is the product of a number and one or more variables. So it'd be like 2x squared. The coefficient is the number in front of the variable. If there isn't a number, it's really 1. Like terms are terms that have the same variable raised to the same power. 2x squared, 5x squared. A polynomial is a term or a finite sum of terms with only positive or 0 integer exponents permitted as variables. No 1 over x's. Now, if the terms of a polynomial contain only the variable x, then we call it a polynomial in x. So these are all polynomials. 6 is actually a polynomial. 8r squared is a polynomial. However, 9x squared minus 4x plus 6 over x is not a polynomial because we have a negative exponent here. The greatest degree of the polynomial is of any term of the polynomial is the degree of the polynomial. So if I have 4x cubed minus 2x squared minus 3x plus 7, this is my highest power, and my degree is 3. It's the power of the largest exponent. If I have negative 6, this is really negative 6 to the 0, so this is degree 0. If you have more than one variable, the degree of the polynomial is the sum of the exponents appearing on the variable in the term. So if I have negative 3 times x to the 4th, y cubed, z to the 5th, you add the exponents 4, 3, and 5. So the degree of this term is 12. While the bottom one, you're going to add 1 plus 2 plus 7 to get a degree of 10. Now, if you have more than one variable, the degree equal to the greatest degree of any term appearing in the polynomial is the degree of the polynomial. So if I look at this one right here, and I have x to the 4th, y cubed, that is highest power is 7. 5 and 1, that's a 6. 6 and 2 is 8. So the highest sum of the powers is 8. So this is the degree 8. A polynomial that contains exactly 3 terms is a trinomial, just like a triangle. A 2-term polynomial is a binomial, and a single-term polynomial is a monomial. So let's identify these as polynomials or not. This first one is a polynomial, and it has, let's see, it has 3 terms. So it's a trinomial, and it's, we wanted the degree, so the degree is 5. This is a polynomial. It has degree 4 because of this term right here, and it is binomial because I have 1, 2 terms. This one is not a polynomial because I have the 1 over y in there. Polynomials are added by adding coefficients of like terms. They're subtracted by subtracting coefficients of like terms as well. So if I wanted to add or subtract these, you need to go through and find the like terms. So x cubed has 17 and negative 9. X squared is negative 10 and 10. And x has 1 and negative 5. So when we group these, we get 8x cubed this way minus 4x. For problem B, m to the 4th has negative 6 minus 1. Now remember, we're going to be subtracting, so it's going to be minus 1. M squared has negative 11, and then we're going to subtract negative 6. So that should be subtracted negative 6. Need the subtraction in there. And then it'll be 21 minus 35. So this becomes, what, negative 7 m to the 4th? And this negative becomes a positive. So negative 11 plus 6 is minus 5m squared. And 21 minus 35 is 14. So now if I want to add these, the powers have to be exactly the same. So in this case, I have r cubed s to the 6th. So I have a 10 plus a 25. And then I have r to the 6th s cubed. So it's 5 minus 15. So it's 35r cubed s to the 6th minus 10r to the 6th s cubed. Now this one, you're going to have to go ahead and do that distribution first. All right? You've got to distribute the 6 to all the terms. And then you also have to distribute this negative 4. And when you do that, it actually turns into a sum. So you have negative 6z squared minus 6 times 5z plus 6 times 3 minus 4 times 3z squared minus 4 times negative 2z minus 4 times 9. Simplifying these, doing the multiplication. Now you collect your like terms. So it'll be negative 6z squared, negative 22z minus 18. Now remember, when you do multiplication, you need to use your distributive property first. So I'm going to take 3x and multiply 3x by this polynomial. And then the negative 4 and multiply by the polynomial. So you have the two different terms here. Double distribution can get a little confusing. So sometimes it's easier to do it this way. And now we're going to distribute again so that 3x goes to 2x squared, 3x goes to minus 3x, and 3x goes to 5, etc. After you have done the double distribution, you do the multiplications. So 3 times 2 is 6, x times x squared is x cubed, and so on. And then you can combine like terms. There are no other x cubed terms. Here are the squared terms, the x terms, and then the constant term. So your answer is 6x cubed minus 17x squared plus 27x minus 20. Now you can also multiply vertically. This is a lot like you multiplied numbers. Put like terms in the same column. It helps keep you organized. So the first thing we're going to do is we're going to take negative 4 and we're going to multiply it by 2x squared minus 3x plus 5. And that gives us minus 8x squared plus 12x minus 20. Then we're going to go to the next row and we're going to multiply 3x by the 2x squared plus 3x plus 5. And you always want to line up your like terms. So that way you can add straight down. So you get 6x cubed minus 17x squared plus 27x minus 20. You can do these with the geometric model where you make a table. So you have 3x squared minus 4x minus 1 on one side, and then x cubed plus 2x minus 8 across the top. And now you're just going to find the area of each rectangle. If this rectangle has a height of 3x squared, a width of x cubed, when I multiply those together, I get 3x to the 5th. For the next rectangle, I get 6x cubed. For the last rectangle, 3x squared times negative 8 is negative 24x squared. When I'm done with the first row, I go to the next one. Negative 4x times x cubed is negative 4x to the 4th. Negative 4x times 2x is negative 8x squared. And then negative 4x times negative 8 is 32x. For the last one, I'm going to multiply 1 times x cubed and get x cubed. 1 times 2x, and that's 2x. Negative 8 times 1 is negative 8. And what I like about this model is if you've lined everything up, it's pretty easy to find your common terms. So there are no more x to the 5th. There are no more x to the 4th. Here are my x cubes, so I can add those. Here are my x squares, and then my x terms, and my constant term. Had I written this so I had no missing terms, I would have been able to just add them straight along the diagonal. So my answer is 3x to the fifth minus 4x to the fourth plus 7x cubed, 6 plus 1, minus 32x squared plus 34x minus 8. Now, I don't care how you multiply them. So if I wanted to multiply 4t minus 5 times 3t squared minus 2t plus 7, you can do it vertically. And when you do, I'm going to multiply negative 5 times 3t squared minus 2t plus 7. So that's negative 15t squared plus 10t minus 35. And then I'm going to multiply 4t times the top, and that gives me 12t cubed minus 8t squared plus 28t. Then I'm going to add straight down. My answer is 2t cubed minus 23t squared plus 38t minus 35. You can use FOIL to multiply two binomials. FOIL, remember, stands for front, outside, inside, last. So the front terms are 7y and 4y. The outside terms are 7y and minus 5. The inside terms are 3 and 4y. And the last terms are 3 and negative 5. So this becomes 28y squared minus 22y minus 15. To do this product, 6p plus 11 times 6p minus 11. You do the front terms, outside, inside, last. And I wind up with these two cross terms here, 66p minus 66p plus 66p, which cancel each other out. So you wind up with 36p squared minus 121. Now, how would you do a product like this? Well, what I recommend you do is go ahead and multiply out your two of your terms. In this case, we used FOIL on the 2x minus 5 times 2x plus 5, and just carry that x cubed along with you. Just bring it down. So this becomes front is 4x squared, outside is plus 10x, inside is minus 10x, and last is negative 25. Simplify this as best you can. Those two cross terms go away. No, they don't always. And now we can use distribution so that we have 4x to the fifth minus 25x cubed when we take and distribute this into both terms. Now you're ready to learn some special products. If you add, or excuse me, if you multiply x plus y times x minus y, and you do the distribution, I think you noticed our cross terms were going away. And the answer becomes x squared minus y squared. This is called a difference of squares. You don't actually have to do the multiplication anymore if you can remember this special product. If you have something like x plus y squared and you multiply it out, you're going to get what's called a perfect square trinomial. And that is x squared plus 2xy plus y squared. Now, if instead of a plus there's a minus, the square of x minus y squared is x squared minus 2xy plus y squared. Remember, the square of binomial has 3 terms, not 2. So let's find these products. This first one is a difference of squares, all right? Or we recognize it as the product of a minus b times a plus b. So it's going to be a squared, which is 7 squared m squared, or 49 m squared, minus b squared, which was 100. Here we have another difference. So this is going to be 16 r to the fourth minus 81. Now this one's getting a little bit more complicated, but it's the same process. It's still a minus b times a plus b. So it's going to be 25x to the fourth, you square that term, minus, you square the last term, which is 64y to the eighth. Now this is a perfect square. So we can use the a plus y, or x plus y squared is x squared plus 2xy plus y squared. And we really don't have to show any work in this case. And the first term is 8z. So 8z squared is 64z squared. We want twice the product of 8z times 30 times 3, and that's 48z. And then we square the final term. This is a difference of squares. So 5z squared is 25z squared. We want minus twice 10 times 12, which is 120. Z cubed, hard to say, plus 12q 12q cubed squared, which is 144 q to the sixth. I won't make you say that in class. Now suppose I want to find this product right here. The first thing you can do is recognize that this is a plus b times a minus b, and that this is going to be a difference of squares. So that just becomes 4x minus 3 squared minus 7y squared. And if I multiply out this term right here, I get that to be 16x squared. And then it's going to be minus 2 times 4 times 3. So it's minus 24x plus 9. And then minus 49y squared. Suppose I want the product of a minus b to the fourth. Well, this is just a minus b squared times a minus b squared. So if I multiply these two both out, I get a squared minus 2ab plus b squared times a squared minus 2ab plus b squared. And so if I just do the distribution one term at a time, I get a to the fourth minus 2a cubed b plus a squared b squared. So that's the first term. And then it's going to be minus 2ab times a squared. So it's minus 2a cubed b minus 2ab times minus 2ab. So that's plus 4a squared b squared. Then minus 2ab times b squared is minus 2ab cubed. And the last term is going to be, let's do it in 3, b squared times a squared. So it's a squared b squared. B squared times minus 2ab. So it's minus 2ab cubed. And then b squared times b squared is b to the fourth. We're going to need to collect like terms. And we wind up with a to the fourth minus 4a cubed b plus 6a squared b squared minus 4ab cubed plus b to the fourth. Now, as I get more complicated, just be patient. For this one, I would rewrite this as s plus 4t squared times s plus 4t. FOIL out the first term. So it's s squared plus 8st plus 16t squared. And now do your distribution. So it's s squared times s is s cubed. And then 8st, let me switch pen colors, 8st times s is 8s squared t. And then 16t squared times s is 16st squared. Then let's go on and multiply everything by the 4t. So s squared times 4t is 4s squared t. 8st times 4t is 32st squared. And then 16t squared times 4t is 64t cubed. I hope you realize it doesn't matter. You don't have to do the first one, second one, third one exactly as is every time, but you do need to find a pattern that works for you. Now you collect like terms. So you get s cubed plus 12s squared t plus 48st squared plus 64t cubed. Now, the quotient of two polynomials can be found with an algorithm, and both polynomials have to be written in descending order to use this algorithm. So suppose I want to divide 12n cubed plus 11n squared plus 5n minus 8, and I want to divide it by 3n plus 2. Write it just like you would have written division of numbers, with your numerator being under the division bracket here, and your divisor being outside. Now, the first thing you want to do is say 3n goes into 12n cubed how many times? What do I have to multiply 3n by to get 12n cubed? And the answer is that is 4n squared. So now you're going to take 4n squared and multiply it by 3n plus 2. So 4n squared times 3n is 12n cubed. And then 4n squared plus 2 is 8n squared. Remember to multiply this by the entire divisor. Now you're going to subtract. Those terms are going to go away. And you get 3n squared plus 5n. And now 3n goes into 3n squared how many times? That is, what do I have to multiply 3n by to get 3n squared? And the answer is n. So I'm going to multiply n by 3n plus 2. So that is 3n squared plus 2n. Then I'm going to subtract. When I subtract, those go away. So I'm left with 3n minus 8. Now, how many times does 3n go into 3n? Well, just once. All right. So I'm going to multiply 1 times 3n plus 2, and then I'm going to subtract, and I get negative 10. So my answer is 4n squared plus n plus 1 plus the remainder, which is negative 10, divided by my divisor, which is 3n plus 2. Suppose I want to divide 8x to the fourth plus 12x squared plus 7x minus 18 by x squared plus 2. I want to set it up, but this time you need to remember that you need to insert your missing terms. So you need to rewrite this as x squared plus 0x plus 2. Divided into 8x to the fourth plus 0x cubed plus 12x squared plus 7x minus 18. This will help keep you straight as you go forward. So x squared goes into 8x to the fourth, 8x squared times. So when I multiply 8x squared by x squared plus 0x plus 2, I get 8x to the fourth plus 0x cubed plus 16x squared. And then you subtract, and you get negative 4x squared plus 7x minus 18. So x squared goes into negative 4x squared minus 4 times. So you multiply negative 4 times x squared plus 0x plus 2, and you get negative 4x squared minus 0x minus 8. And then you subtract. So when you add straight down, you get 7x minus 10. So your answer is 8x squared minus 4 plus this whole thing, 7x plus minus 10 divided by x squared plus 2. And it's okay to leave your placeholders at that time.